we're really excited to be here today, and we have a great turnout. So I'm very excited to welcome David, and very much looking forward to this conversation. I think there's so much that we can learn from Schaeffler, and I think they have a very unique positioning in this physical AI ecosystem. So just to start, David, I'd love to just ask you a little bit about where do you see the physical AI landscape moving today, and what do you think is actually driving the shifts today?
Yeah, I guess it's no secret. It's moving fast, and it seems every day that it's moving faster. And so we see that every day more and more opportunities come up, more and more opportunities where we can get involved, not only as someone who is delivering components, but someone who is also using these physical AI robotics inside of our plants. So these two areas kind of come together, and every day it gets faster.
So I really want to dive into more about what Schaeffler is doing, and I think the thing that really draws my attention is that you have a really rich history of innovation and technological development that's actually spanned over 80 years. And when we think about companies today, we're often thinking about companies that have emerged in the last decade or even in the last few years that are just starting to build and innovate. But because of this rich technology that you already have, how much of that do you think has been a key driver in terms of you being able to make this pivot, leverage your existing capabilities, and really provide an early entry point into the physical AI space?
Yeah, it's a great point. So it really is an interesting experience having this 80 years, having all of this DNA, and then trying to harness it, as I mentioned before. This whole physical AI is accelerating. So what we have to do is be able to extract and utilize the resources, the competencies that have built Schaeffler up over these 80 years, and we have to do that at a fast speed. If you have all these competencies and you can't leverage that at a fast speed, then it doesn't do us any good. So that's one of the things we spend a lot of time on is, yes, we have this innovation, yes, we have this huge manufacturing footprint with over 100 plants globally. All of these resources, we have to harness this in a fast way, and so it's really flexible communication. It actually starts with how we're set up inside of our company. So my group does not belong to the automotive side, it does not belong to the industrial side. It's separated out, and we report to the top of the house. So everything is done with agility and speed in mind.
So it feels like it's very strategically important for Schaeffler to go into the physical AI space, and you're already doing a lot of work with humanoid robots. Can you tell me a bit more about why you think it's just so strategically important, and maybe what you're looking to be able to achieve by being that early entrant?
Yeah, I think first of all, from the top of the house on down, our CEO and the executive board is very bullish on physical AI. We see that as a need. Whether it starts with a lack of a human workforce that we will have. We actually have issues in parts of the world today finding workers to work in our factories, and so that is an immediate need that we have, and that is helping push us into wanting to deploy these. And then on the component side, we see this as a natural pivot. We do actuators today, we do bearings, we do transmissions, e-motors, controllers. We have all of this technology in-house for automotive or industrial, and it's a natural pivot then to carry this over into the physical AI space.
I think the actuators component is very interesting because you're actually building a lot of the components and actually working with a lot of what people perceive to be the leading humanoid companies in the world. Can you tell me a bit more about what you think some of those technical challenges are that they're facing today, and maybe the role that you're playing in actually helping address those technical challenges?
Yeah, I think the big one out there, and it's the elephant in the room if we use a term out of America, is scaling. So it's nice today, everything is built more or less like prototypes, it's tested in labs, and that will change with the training, with the AI improving, that we will be able to deploy these much faster. And if we want to deploy these, we will need technologies, manufacturing technologies that enable scaling. And you won't be able to put in, we say, football fields worth of machining equipment. You will not find the machines, and so you have to do something different. And that's where we get into, let's form parts instead of always machine them. And that takes seconds instead of minutes to do the machinings. And so that's really the space that Schaeffler wants to play is how can we scale? And that's one of the biggest challenges we face.
So I think you touched on the fact that we need to get from prototype into production, and I definitely see that as being one of the biggest challenges in physical AI as well. So everyone is building, 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 but facing challenges once you actually start to scale in deployment. Are you able to share a bit more about Schaeffler and some of the use cases that you're working on and how you're starting to put this into production, or how some of your customers are starting to do this? And maybe from there, share a bit more about how you think this ecosystem looks like in terms of what needs to happen to really actually go from being in the lab to out there in the real world and delivering ROI.
So one of the first things we learned, and it was one of the first things that kind of smacked us in the face, is you just have to start. So you should do some upfront work. And what we did is we identified use cases inside of our factories, and we came up with 6 different use cases that is used. All of these 6 use cases are used in most of our 100 manufacturing plants. What we wanted to stay away from is one unique, maybe cool use case that only one plant in the world could use, and that just doesn't make sense. So once we have the use cases, you have to then dive in, find the right partners, and we found a number of these partners globally to where you can cooperate, because nobody understands everything today. Our OEMs don't, the industry doesn't, Schaeffler isn't, we're all on this learning journey together, and there's no better way to learn than to just get started. And so the use cases we're looking at, for example, is logistics and carrying steel totes over to a parts washing machine. That we paid a human laborer to do that today, and now we've replaced it already in one of our manufacturing facilities with a humanoid. And that person then is somewhere else in the plant doing higher value tasks than what they were doing before, just carrying a tote from one side of a machine to another. But we learned things about the color of the floor. Is the floor shiny over here and dull over here? And all of that had an effect on the robot's sensors, for example. The Wi-Fi stability, it was fine for the rest of the machines in our plants, but it wasn't good enough for a humanoid. And so these are all things that we're learning now that would be much more expensive to learn later on, and much more problematic if we learn these later on. So we're just diving into it, doing the homework on the use cases, and then finding partners to execute these use cases inside of our plants.
So it feels like basically, because you've got this deployment scenario and you're already deploying this into your robots, that can then actually help you when you actually develop the technology and from the start be able to then continue to iterate. Like, is there something particular that you've been able to change as a result of some of your learnings from deployment?
For what we see today is some of the products, if we talk about actuators, there may be off-the-shelf actuators, or actuators are over-engineered. And a real benefit for my team, who is developing and industrializing these components and systems for humanoids, is we can go next door where we're deploying these, and we can actually collect data. We can see what our components actually need to do. What is the torque necessary? What are the speeds necessary? Is it overheating? And we have this data right in our own house. And so that kind of sharing is really created kind of an internal flywheel, development flywheel inside of Schaeffler.
So I think that sounds very valuable for your partners, because a lot of the people who are building don't necessarily readily have those access to those deployment environments and a lot of this real world experience to go and drive that. It's interesting because right now, it feels like a lot of the work that you're doing is with humanoid robots. Do you feel that that is the form factor that is going to be critical, like going forward? What are your thoughts on humanoid as the form factor?
The form factor to us, we're really agnostic. We want to follow a best in breed, if you will. So for a use case, what is the best application? What is the best customer robot out there that can do that most efficiently and generate the most value? And so form factor isn't so important for us. What is a factor is we have 100 manufacturing plants, and we don't need 150 or 200. So all of these dark manufacturing plants, which there will be some, is important, but even more important to Schaeffler is how do we convert these brownfield plants that are already existing, that were already designed for humans, how do we make the humanoids or the physical AI work in these factories? And so some cases they will need 2 legs and 2 arms, in some cases they will need 4 arms and 2 wheels. It just depends on what the use cases is and how the plant is set up.
I guess there are a lot of companies that are out there that have, similar to Schaeffler, 80 years or a very long, rich history in their particular industries. What advice would you give them in terms of how to make that leap forward, because I think actually you're one of the few companies that I've come across that has really been able to make that jump in terms of innovation. So what's different that other people should be thinking about? Because they probably have the same pain points in terms of challenges with the labor shortage, maybe it's access to the remote environments. It feels like these are very common problems, but I'm not seeing a lot of companies that are actually being as successful in terms of solving it.
Yeah, and what you're seeing is a result of many tries that we made, many attempts, and they didn't always go perfect. So
Right.
I would always encourage people, it starts from the top of the house, and you need to be brave. So if you're a COO, you're an executive here, you need to start trying. Yes, do some homework up front, but you can't do homework for the next 2 years to try and figure out the perfect solution and make sure everything is covered. You need to just try and be brave, and if that's supported from the top of the house, from the executive level like it is at Schaeffler, it makes it much easier.
So is there kind of like a balance in terms of how do you trade off against trying to innovate and build as you fly and actually get to deployment? Because some of the use cases that you mentioned, it feels like you would have invested time to actually find those use cases. What makes it ready or like good enough for you to actually be able to go and actually start deploying in that? Because that is actually a big leap, right?
So what we try to do is we try to identify the use cases, then we have a short planning phase with the customer OEM, and then we bring them in and have a designated area where we perform this proof of concept. And we have a great team inside of Schaeffler that does deployment. It's our advanced production technology team, and they do this ahead of installing it directly into a plant. So we have robo-gyms in the different regions where we will test this out first, and then we will bring the POC into the plant. So there is a little upfront work, there's a little lab work that directly simulates the use case. So we have the same machines, we have the same conveyor belts. All of the environment in that immediate area is very similar to what the humanoid would find in the plant. And then once we confirm that we're ready to go into the plant, then we deploy it into the plant.
Tell me a bit more about the robo-gyms. Do you think that's something that's like an absolutely critical step for you to be able to get from prototype to deployment? Is that something that's on the rise? Are you building more of these robo-gyms? Do you think the industry in general will use this as a form to get to deployment?
Yeah, I think so. I think there'll be different forms of these robo-gyms. If we look at China, this will be more communal.
Right.
So there will be competitors as customers that are bringing their robots into our robo-gyms. And in China, we are creating, already is built and nearly ready to open. We will have a grand opening in October, where we will actually have a robo-gym data collection, and we will produce actuators on site for humanoids. So in theory, customers will bring in their humanoids, they will train on our specific use cases, they will go around the corner and build components for themselves.
Okay, well, I mean, that sounds very cool.
That kind of flywheel is going to be exciting. We think it's the first one like it in the world.
It's interesting because, I mean, it feels like now you've got it kind of contained an environment where you could actually build and then actually go and do the production. And this based in China, I noticed that Schaeffler is actually very much global. You're already operating in over 50 different countries in the world. And you have partnerships with companies across different regions in the US, Germany, France, China.
Yes.
Can you tell me a bit more about how you're utilizing the global ecosystem and whether there's any interesting observations you have about how to work with different parts of the world and maybe what special areas of expertise or innovation that they're bringing?
Yeah, I go back to the speed first of all. So no matter where we work in the world, this industry is fast. So this doesn't change really.
Yeah.
Maybe some are a little slower, some are a little faster, but it's still coming quite fast. You see China and the US, just because of the AI, has typically been considered the leaders, but don't count out Europe. And I think where Europe can play a role is especially on the safety, but there has to be a balance. There can't be so much safety and so much regulation that it stifles the humanoid or physical AI market here in Europe, because there's a lot of companies working on it here, and we have to promote that in Europe, and that's coming from a German manufacturer. We want to see Europe succeed. You see a lot more service robots, I would say, in China, but they also are doing industrial robots, and you see more of a focus in the US on the manufacturing use cases as well. So you see a little bit of difference, but in the end, it's all fast and learning every day.
I mean, aside from the use cases, right? So I think definitely there's different focuses in different geographies. Do you feel like from a capability or technology perspective, you also lean on different partners for different areas of expertise around the world?
Yeah, so we have different kinds of partners. Certainly we have OEM partners who we work with and share this learning journey. But we have partners like NVIDIA. And so every day I hear from my team about how we're deepening these relationships, especially with companies like NVIDIA. With NVIDIA, for example, we're creating digital twins of our actuators.
Okay. Yep.
So if we talk about speeding up training, reducing the sim to real gap, part of that is going to be having actuators simulated that actually are simulated like they perform in the real world. And that's what we're working on with some of these partners. So this partnerships that we created, if it's from NVIDIA to all of these OEM partners, is really strategic and important for Schaeffler.
I guess like kind of, looking more forward-looking, right? In terms of where do you see the market heading? What do you think is the next big critical step for Schaeffler or for the physical AI market in general in order to get to the next horizon? Because, I mean, this year is actually the first year of Machina, so it's still very early, I think, for most people in terms of thinking about physical AI deployments. What do you see as critical breakthroughs that maybe we need to get to over the next few years, or just how do you see it evolving generally?
I think there's really two areas. The first one is safety. So safety starts with regulations, and I just talked about bureaucracy and trying to minimize some of this, but you need safety standards. There's nothing more important to Schaeffler than the safety of our employees. So we will not deploy anything that's not safe and that does not meet regulations. And today, we don't have a lot of regulations on autonomous robots in our plants. So any deployments we have now are behind glass walls. And these humanoids, they will not bring value if we treat them like zoo animals, that they just stay behind walls. Then we can put in a cobot or an industrial robot, and that's not what we want to do. So safety, we need the regulations, and we need the community to come together to create smart, pragmatic, and safe safety regulations. The second area I would say is training. So today it takes too long, it takes too much real data to train robots. And so we have to get to the point where if Schaeffler receives a robot or a physical AI tool from one of our customers, that it can be up and running by Schaeffler within a couple hours and not a couple days or a couple weeks or a couple months. So these two breakthroughs I think will be key to increasing the deployment rate.
I think, I mean, it feels like right now definitely there is still a very long training life cycle, and you mentioned the role of data. When it comes specifically to data, through all of your deployment, you're obviously accumulating a lot of data for the training. Do you think we'll get to a point, because we're all talking about the data shortage, we're talking about sim to real gap, do you think in the next 12 months we're going to see any significant changes in terms of the ability to do that? And is that something that you're also working to solve?
Yeah, so we have different areas trying to solve that problem. It's not an easy problem. I think the problem we have is the data sits in different systems inside of Schaeffler. It depends on the region, it depends on the plant, and we have to figure out how to get that data out of our systems and then curate it into a form that we can actually use it. And that's going to be the real challenge that we have to help speed up the training, but it's something that we're working on with several of these partners and in different areas of our plants.
And I guess just like the final question, because we're kind of getting to the end of the session and the timer is ticking, but I think the safety standard is very important, and it feels like it's an underrated kind of topic in terms of a lot of people are really just building the plane as they fly. They're not necessarily thinking too much about what they can do, and once you get to deployment, do you think this is something that Schaeffler will be able to lead the way in terms of building some standardizations? Are you working with partners in order to try and better define that? Because I think that's always a big conflict in terms of building new technology and trying to be able to govern and manage it. And I think robots, because they are physically interacting with us, the safety is absolutely critical, especially if we think about going into industrial environments or even into the home. Yeah.
It will really be solved by the community. So Schaeffler, of course, we're learning about safety when we bring them into our factories, but we're also participating with organizations that are writing ISO standards, for example. So not one company can legislate or dictate what these regulations will be. It will be the community that needs to do that. And I think by participating in these organizations and these studies to create these legislations, and then also understanding what we see boots on the ground inside of our factories, this puts Schaeffler in a unique position to support this.
All right. Well, thank you very much, David.
Thank you for having me. Thank you.